Hi everyone, my name is Marty Woznicki. I'm the Vice President of the Neuron ESB product team. I'm here today to run you through a high to mid-level technical demo of some of Neuron ESB's core features. As I go through the demo, I hope you'll see the flexibility and ease of use we've worked hard to build into the platform. For those of you who've never heard of the product, Neuron ESB is an application services and workflow integration platform built entirely on Microsoft.NET. The latter is important, especially if you're a .NET shop, because it means that you can use existing .NET resources like .NET assemblies, WCF, and existing Windows workflows to extend solutions built on our platform. This also means that native Neuron extensions like custom adapters, process steps, and workflow activities can all be written using Visual Studio and C#, letting you use the skills you already have. More importantly, we built Neuron because we thought it was crazy that businesses had to invest in long-term consulting contracts and specialized resources just to integrate their environment. Our goal with Neuron has always been time to market, ease of use, and putting you back in the driver's seat. As you can imagine, as an integration broker, Neuron has a number of capabilities that allow you to solve complex integration problems. Everything from messaging, service brokering, workflow automation, and general integration come out of the box. In fact, every feature in Neuron ESB is out of the box. Throughout our demo, we've spent a lot of time showing you how to leverage features of Neuron ESB to solve integration problems. But once Neuron solutions are built, operationally, they need to be managed. Failures need to be detected, performance measured, throughput monitored. Neuron provides a number of tools and APIs that allow users to get insight into these operational aspects. For example, within the Neuron ESB Explorer, users can enable message tracking as well as failed message support. They can view, edit, and resubmit any message tracked or any message that failed. They can monitor the throughput and status of any endpoint through the Neuron ESB Explorer's Endpoint Health tool. Additionally, runtime logging information is written to a dedicated Windows event log, as well as to native Neuron endpoint text logs. Now, for those seeking more customized monitoring solutions, Neuron exposes monitoring capabilities to a set of WMI performance counters and events. Lastly, Neuron provides a REST-based API that exposes all of these features, as well as providing access to audited and failed messages. Let's take a little time and walk through some of these. Monitoring is viewed, managed, and configured directly within the Neuron ESB Explorer. As we discussed earlier in the presentation, several ways to monitor a Neuron ESB solution, really depending on the activity and the features that you're using. Now, for most solutions, monitoring can be done through message tracking, which we call auditing, as well as endpoint activity monitoring. Now, to enable message tracking, and arguably, more importantly, failed message tracking, this is when something fails in the system and there's data to capture, that Neuron ESB database has to be created and assigned to the active deployment group. Now, this is pretty easy. We've done this in the past. Just go to Deployment, Manage Databases, hit New, your server name, for local. You have to enter in the name of a database that we're going to create. In other words, it can't already exist. This will create a new one. So Neuron July DB. There we go. When you hit test create, we'll actually create a new database, populate it with all of our objects. Not only will a database be created, but also a SQL agent job to keep things cleaned up. And if you want to grab the connection string, you can always modify the connection string properties through the edit button and even copy that connection string out in case you want to use it for an environmental variable. Great. Also, you have to make sure that you add things to it like local system, if that's what you're running the Neuron runtime under. All the users using the Explorer, as well as a runtime user, have to be added here. Hit apply. Perfect. Now what I need to do is simply add it to a deployment group that might be using it. I already have one for development. That's my active one. I can always assign this to the production one. And it's that simple. Hit apply and save. And which deployment group your runtime is running, that's usually done through configure server. Come here, all your deployment groups show up in a drop-down box. That tells the runtime which things to load. So it's that simple. Now you have a database. Great. You can do auditing in a couple of different ways. Number one, if you're in a workflow or if you're in a business process, you can use the audit activities. That gives you a lot of flexibility and granularity on insofar as what you want to audit, track that is, and exactly where you want to track that message. Now, another way to do it is just through a topic. You can simply hit a topic, select the auditing tab, and just turn on the feature. There you go. You have a variety of events, variety of things you can do. Hit apply and save. That's simple. Great. Now I can just launch a couple of test clients, publish a message, and view the tracking data. Apply a pub, apply a sub, connect, receive, send, Joe, send it, I get it. Now if I go into activity, message history, I can see the messages. Publisher sent, there we go. Subscriber received. So if I want, I could go ahead and simply take this. This is my subscriber. I could simply go ahead, take the original message. This is me, and republish it back to the system using the same publisher, going to that topic. And hence the subscriber gets the message. Pretty easy. Well, so tracking messages, again, run it. Notice more messages. So let's go ahead and delete these. Remember, you can always create a process and audit the message within a process. Gives you more flexibility. I'll create a process. I'll grab the audit step. I'll go ahead and say, great, sending it to the bus. Notice I can choose to audit the custom properties, the message body as well, but here I have a little bit more granularity. I might decide that I'm only interested in a certain piece of that message to be audited, not the entire body. So if you got large messages, you might want to just grab the piece that you're interested in rather than getting a lot of noise. And hence, because this is a process step, you can use it anywhere within a process. Remember, a process can be pretty big. So anywhere you want, as many times as you want. So I'll just go ahead and call this my audit process. There we are. Hit apply. And I'll just add it right to my publisher. Edit, audit, done, apply, save. Outstanding. Remember, it takes a couple of seconds, things to take effect. Everything's dynamic, everything's self-aware. Click, I've got this, let's change it. Marty, send, went to the other side. Now if I go back in the message history, instead of 2 records, I probably have 3, right? Apply this one from the audit step, this one from the topic, this one from the topic. Pretty simple. I'll go ahead and get rid of these. Now what we want to do though is, let's see what a failed message looks like. Now failed messages are pretty important. Tells you that something's wrong within the system. So any unhandled exception within Neuron should generate a failed message as long as there's a message associated with it. So if there's a failure in a workflow, an adapter endpoint, a service endpoint, say an unhandled exception in a process, those will be captured, be reported as failed messages. Now, failed messages can also happen if you publish to a topic and there's no subscriber. Okay, we'll generate a failed message that way as well. Now, we'll also generate failures if, say, an endpoint can't connect to a system. Now, that might be a failure, but we might not actually generate a failed message for it. Those are controlled by adapter policies. So let's go ahead and take a look at the policies and the adapter endpoint and see what we can do here. So going to connections, adapter endpoints, let's go back to our file subscriber demo. And what we want to do is have this endpoint generate an error somehow, just to see what that looks like in the system. So first thing, I'll enable it, then I'll go to properties, expand the window. I want to route it to a folder that doesn't exist. So there we go, that doesn't exist. And to make sure an error is generated, I'm going to make sure this create folder path is set to false. I'm going to hit apply, I'm going to hit save, we're done. I'm going to shut down my subscriber, by the way. And I can go into endpoint health. Let's see if that's alive. And we can see this is alive now, the endpoint that we just created. Now what I'm going to do is send in this message again. Great. Now what happened? Well, we know nothing went out the file out because that folder didn't exist. Let's go here. Windows event log. Neuron actually installs a Neuron ESB v3 event log underneath applications and service logs. We write all errors and warnings to this log, and you can see, sure enough, here's a warning saying the adapter couldn't find that path. Here's an error saying there was no adapter policy, so we just discarded the message. Hence, if we go here in the failed message, we don't have a failed message. Now I can see more verbose detail because we also write information to a Neuron log file, actually to a set of them. If I open up this folder, you'll find that there's a logs folder in the Neuron installation directory. There's a folder representing each instance that's installed. Now we're using this instance. Every time you restart the Neuron runtime, it creates a whole new folder with a date timestamp. And within this folder are all the log files. There'll always be a log file representing every adapter endpoint, every service endpoint, every topic, some of our internal services. You can see the master service. Scrolling down gives us information about your environment, kind of tells us what to do. And notice debug, info, etc. This logging level is controlled from here. Logging, trace errors, trace warnings, info, verbose. How large will let the log file grow, disk space, logging schedule, cleanup schedule. You can even, and you can turn on WCF tracing if you want to. That'll produce some very large log files. But let's take a look at our endpoint log file. We can see all the properties of the adapter endpoint. There we are. Adapter send called failed, could not find part. Here's your warning, here's the error. Now what we want to do now is actually capture the failed message. So if I go into the Neuron Explorer, connections, adapter endpoint, I can see there's no policy defined. Well, I can add that policy. And if I go into that policy, one of the things I can see is the policy tells me, number one, how many retries, interval between retries, and what should I do? Should I discard the message, log it to a database, etc.? I can even define availability windows. When the endpoint should be shut down, turned back on again. And you can take one policy and assign it to many endpoints. Okay, so let's go ahead and save this. Excellent. Let's run this again. We'll go ahead, send in the message. Let's take a look at that event log. Now, slightly different error. A message has been saved to the failed audit database, tells you the exception object and the error and the entire stack. If I go in here, activity, failed message, now I have a failed message. Gives me all the error information here, all the properties, any custom properties, and I can do the exact same thing, just like I did with a regular message. I can either republish it using a party or republish it directly to an endpoint. Easy to do. Now there's other ways to generate an error. Remember what I said, unhandled exceptions will be caught as well. Now we can show that pretty easily. I'll go back into this adapter endpoint. Let's set this so that it'll be successful. If we send a message through, we'll just make sure the folder exists. But what I'm going to do now is I'm going to create a process. And I'm just going to call this throw exception. I'll add a C# step to this. Throw new exception. There we are. Hit apply and save. And what I'm going to do now is I'm going to actually add this to the on receive event of that subscriber. Let me go here, processes, add, throw exception. So this is going to happen before the actual adapter endpoint gets the message. I'll hit apply and save. Now let me just go back in activity. I just want to clear everything out. Delete, great. Message, run, delete, excellent. Go back to my publisher. And now I'm going to send that message. And now I have a failure. Remember, unhandled exceptions will also be caught. What we have is unhandled exception, hi mom, right? Failed to do, hi mom. Pretty simple. So let's go in and we'll just clear these out. We don't need these anymore. Let's remove them. I'll go ahead and do the same for publisher. There we are, and I'll hit apply and save. So message tracking, failed messaging, pretty easy within Neuron. We can track messages pretty much anywhere, anytime, anyhow. Failed messages, we'll catch these where they occur. On endpoints, policies just have to be defined. Even if you had a custom business process, you might do something like this. Let me just remove this, and I'll put a try catch. Here's a very common pattern. You might decide, great, you can press something, but if something fails, that's okay. I don't necessarily want it to go anywhere. So cancel will be the final step, but on the audit, I'll set it to failure. And when you set it to failure, it will actually automatically capture the exception that occurs, grab all the details, and log it to our failed message database. Kind of a common pattern. There we are. I'll close these. Now let's go back into endpoint health. We've been in here a couple of times, right? This is where you can see a lot of metrics. You can see the state of all the endpoints. Notice I've got things disabled. I've got things started. You can see workflow. Each availability group, it's a hosting environment. All of its workflow endpoints will be underneath. Right now I have this disabled, hence everything's gray. As messages are moving through back and forth, you can see things going on. Notice 6 messages, great. I can also do other things with this. I can restart or stop the service. Just go ahead and restart this. There we are. And this is basically polling about every 10 seconds. You can modify that through tools options, how often you want the check to see state. This action is actually quite immediate, but again, we've got like a 10 or 15 second polling interval going on right now. Now, all the information that you see in endpoint health, this is all through the Neuron Explorer. All of this is available though through the Neuron REST site. Neuron exposes a REST API to get all of this information. So the Neuron ESB REST API can be accessed through localhost port 51002/help. That's the default URL. You can see it right here. We expose all of our functions through this. Message activity, deployment information, endpoint health. You can even change the state of endpoint health, as well as all the runtime information. You can actually stop runtime instances, as well as change their configuration just using the REST APIs. Getting deployment information, as easy as typing in the instance name, default 1011. Great, I can try that out. I can get everything back. I want to take a look at endpoint health information. Again, 1, 0, 1. Here we are, try it out. And I can get back. Notice I have Playa, it's in a started state. This is a GUID for it. If I go back to endpoint health, I can see that's the topic for it. If I want, I could go ahead, type in the instance, the ID, default 1011, and choose to restart it. Although this might pick it up, this might not pick it up simply because it's going to be too fast on the REST side. There we are. In any case, you can do all these operations directly through the REST API. Pretty easy to do that. Now, besides REST, we also expose a lot of this same information here. All these metrics, we expose a lot of the same information directly through WMI performance counters. Now, the nice thing about that is that most Microsoft-based products, even non-Microsoft-based enterprise products, typically expose health metrics through WMI performance counters. Now, a couple of things you have to understand with Neuron. First, you need to make sure these things are installed. By default, if you go through setup, that's an optional feature. You need it for workflow to run, and ideally, you always want it to run. So if I just go back to my desktop, run the bootstrapper, I'll just hit next, next, go to the right to the features, ESB service management objects. Simply always make sure this is checked. If you're installing using the MSI package instead, by default, it's going to get installed. The other thing you need to make sure you do for all of these, go to deployment zones, click on your zone, go to the server tab, and you can see there are performance counters that you can enable or disable. So by default, I think we enable all the parties, but we disable Neuron topics and endpoints. You can see I have that enabled. Once you enable those, you'll need to restart the endpoint server. But once that's done, you can track everything through tools like Performance Monitor. Okay, let's try some of that out. I'm going to go ahead and just launch a couple of test clients. There we are. And I'll do Playa Pub, connect, Playa Sub, connect, send, great. And going into endpoint health, I can certainly see we've got some metrics, right? There we are, 6 messages. But if I go into a tool like perfmon, let's come in here. I'll just go ahead. I don't need the CPU. Perfect. Add it. Scroll to Neuron. There we are. So notice we have a number of WMI objects. One for availability groups, endpoints, parties, topics, workflow endpoints. Now in this case, we have topics and parties I'm going to track. Things will only show up down here if things are enabled. So in this case, I want to hit message, processed, grab that for the topic. And I could even do parties. Message sent, messages received, rate per second. And I'll just go ahead and say this is for, there we are. I'll do all of those. Let's make sure we have something going on here. Adapter endpoint, that's actually enabled. Folder's good. There we are. We'll just go ahead and take that off. Let's clear this. Let's go into our test client publish, and let's see if anything changes. There we are. As we're sending the messages, one of the things that we can see is messages being received, messages being sent. Topic, messages. So you can capture all this information via just WMI performance counters. Pretty easy to do this. Now, besides WMI performance counters, we also support things like WMI events. WMI events are kind of nice, complementary to certainly the performance counters, because we can capture when something happens. Now, specifically, let me go ahead and I'm going to shut this down, come back in here. Let's go back into endpoint health. There are states here, disabled, started. I can go into Playa and I can say, let's just restart this. We did this once before. You might want to know when certain events happen. Certain endpoints are being restarted or stopped, certain things are being disabled, or even when messages fail. You can capture all those kind of events with WMI. And the nice thing with WMI is that it's technology agnostic. There are no dependency on Neuron DLLs. WMI code you can write in script if you want to. It's an event-based programming language of Microsoft's. Pretty easy to work with. Now in this case, I actually have a project using WMI. System.management namespace, our management scope, just like this. I connect. We expose a failed message event. We also expose an endpoint state change event. I've got watchers created for both. And notice with WMI, you can actually create query-like constructs for this, determine exactly what you want to monitor and when you want to do it. Now here, if an endpoint changes, I can actually grab all the information with this, and I'm just writing it to the console. So things that we capture when the state changes, things like the zone, what type of endpoint, the name, what the state is, the host, the instance name, application name, deployment group, ID, and the message. If a failed message occurs, we capture pretty much a lot of details around that failure. Certainly the failure itself, the message body, things about ambient properties, things like topic, party ID, session, the instance name, the message ID. If it's a large message, and here I've just got some optional code to say, hey, you know, if this is larger than a meg, then go ahead, just make a REST call, bring it back, or call directly to a database. I'm just writing it out to a console. So if I go ahead and I'll just run this in debug mode. There we are. Let's go here. I've got this running. I'll go ahead and restart this again. Bring this down a little bit so you can see it. Restart. Pretty simple. I can do the exact same thing with adapter endpoints. In fact, let's go ahead and see what capturing a failed message looks like. We'll go back to the adapter endpoint this time. Modify this, just like so. Let's make sure create folder path is still set to false. And notice what happens. I'll hit apply and save. Remember how I said in the past, the runtime instance, client API, they're all self-aware change. They'll see something, recycle what's necessary. If I hit save on this, here we are. Runtime will pick it up. And notice state changes, right? The runtime recycled the adapter endpoint because it saw we actually changed some properties. So now if I try to run a message, let's make sure here, failed messages, nothing here. We're going to publish this message, and we know it's going to generate a failed message because we have a policy assigned to that adapter endpoint, and the adapter endpoint is configured to write to a directory that doesn't exist. There we go. So I have my failure here. I can see it's a system IO directory not found. And if I come here, I can see that failure message on instance, topic name, etc. Here's the exception information, the entire stack, and the ID. All right, so can capture everything just with events. So pretty powerful that you can capture things with events. Now, notice we captured that failed message. Now, there might be other uses for this. Now, imagine you might want to capture a failed message, or anytime a message fails, capture it and forward that to maybe a separate process, a separate database. Maybe you want to email it out to something. Now, the beauty of this is Neuron still has pub sub in the middle. There's no reason why this kind of WMI event code can't be turned into a publish side adapter. And hence, these failures would automatically be published back into a bus where you could create subscribing endpoints. Maybe it's an SMTP subscribing endpoint. Maybe it's a database subscribing endpoint. Maybe it's a workflow that's a subscribing endpoint, and its job is to process this based on the metadata. So that's exactly what we've done. In this case, I have a sample adapter using this same event-based API, capturing the failed message. The adapter name, Neuron failed message event adapter, has custom properties associated with it. So if I come down, here's the event that gets fired, right? Notice failed message event here, try. I'm capturing the information, and then what I'm doing is I'm adding a lot of this kind of information as metadata to the original message. And here, I've got an option in the adapter built, either retrieve it directly from the database or retrieve it via REST. And then I'm just publishing a new message to the bus. It's that simple. Doing this, you just simply right-click, build the adapter, and then all you're doing is copying the assembly to the adapters folder. So if I come back here, show my desktop, you can go into the adapters folder, and you can see that's exactly what I've done. I've copied the assembly right in here. So now to use this, all I really have to do, let's close this. Let's delete this. Go into connections, go into adapter. Let's register the adapter. There we'll go, and we'll say Neuron failed publish adapter, like that. And I'll just select it from the list, Neuron failed message event adapter. Great. Once I register an adapter, I can, of course, create one. And I'm going to create this, select it, Neuron failed message adapter. It has one mode, publish. I'm going to associate it with the Playa publisher. And I'll call this my failed message publish endpoint. And I'll say publish to the Playa topic. Hit apply, hit save. That's simple. I'll go ahead and bring up a subscriber. This subscriber will subscribe to any messages published by that adapter. Notice the subscription. It can only receive messages on Playa. So now if I take my original test client, notice it can publish messages to 3 different topics. So if I publish a message to V1, no subscribers. There are currently no subscribers set up to listen to those messages. Remember what I said, if you publish a message to a topic and there are no subscribers, that will auto-generate a failed message. Let's see what happens. Let me go back to activity, failed messages, nothing. So let's go ahead and send a message. Now I'm going to go ahead and send this message to Playa V1. Now remember, we don't have anything right now currently subscribing to Playa V1. And remember what I said earlier, if you publish a message to a topic where there's no subscribers, Neuron will automatically create a failed message for this. So I'm going to go ahead and send this out. Notice, just received a message. If I look at it, scroll down, you can see all the custom properties of that failure. subscriber not found, and the actual failure detail of the message. And if we go into Neuron ESB Explorer and go into failed message, you can see that there's a failed message. Same error message. So again, pretty easy to do those kind of things. In this case, I literally just used WMI events, created a publish side adapter, and now I have an adapter that can capture any failed message that occurs and simply publish it to a bus where I can set up any number of subscribing endpoints to process that failure. That's what I was going to show you. Let's move on to the next section. I hope that we were able to convey the richness and ease of use built into many of the Neuron ESB features. We work with our customers and our partners each day to get the insight we need to provide you with a better experience. Integration shouldn't be hard. That's why we built Neuron ESB. An evaluation version of Neuron ESB can be downloaded from our website at www.neuronesb.com. We look forward to hearing from you. Thank you again.